Hi there, Mr. Miah here from R Squared Tuition, and in today's tutorial we will be going over quadratic simultaneous equations. So let's talk about what simultaneous equations actually represent. So when we look at the graph on the left hand side, we have two linear graphs intersecting. These points of intersection are what we refer to as the solutions of the simultaneous equation. These two linear simultaneous equations clearly give us one solution of x and one solution of y. If we look on the right hand side, we can see that the linear graph intercepts the quadratic graph at exactly 2 points. Therefore, we get two solutions of x, x1 and x2, and we get two solutions of y, y1 and y2. So this is a graphical representation of simultaneous equations. We can also use algebra to solve them too. Let's look at question 1. Y equals x plus 3, y equals x squared plus 5x minus 2. So I'm just going to label it as equation A and equation B. If you notice, both of these equations equal to y. So x plus 3 is equal to y, x squared plus 5x minus 2 is equal to y. That means we can make both equations equal to each other. So equation A is equal to equation B. X plus 3 then is equal to x squared plus 5x minus 2. So you can only solve a quadratic if it is equal to 0. So I want to make the left-hand side equal to 0 by subtracting x from both sides and subtracting 3 from both sides. So now the left-hand side is equal to 0, and the right-hand side is going to equal to x squared. 5x take away x is positive 4x. Negative 2 minus 3 is equal to negative 5. So in order to solve this quadratic, I'm going to factorize it. So I need two factors of negative 5 that add to give me positive 4. The combination must be 5 and 1. And in order to get 4, it must be negative 1. Come back onto the left-hand side. I've got x plus 5 brackets x minus 1 is equal to 0. For my first solution of x, I'm going to have x plus 5 is equal to 0. Therefore, x must be equal to negative 5. And for my second solution of x, it must be x minus 1 is equal to 0. Therefore, x is equal to positive 1. Just going to box them off so it's clear what my answers are. And now I'm going to work out my y variable. In order to work out my y variable, I just need to substitute these x variables back into equation A or in equation B. Now, because I can use either equation A or B, all I have to do is pick the easiest one. I'm going to pick the linear one in that case. So for my first solution, y is equal to x plus 3. Therefore, it's negative 5 plus 3. Y must equal negative 2. For my second solution, when x is equal to 1, y is equal to x plus 3. Y is equal to 1 plus 3 then. Therefore, my second solution of y is equal to positive 4. And again, all you got to do is clearly state x is equal to negative 5, then y is going to equal to negative 2, or when x is equal to 1, y is going to equal to 4. And you can just leave that as your answer. Okay, moving on to this question, we have equation A, which is non-linear, and we have equation B, which is linear. The way we know that is there are squared terms involved in equation A and linear terms in equation B. So we only have y to the power of 1 or x to the power of 1, and we just need to make one of these the subject. I'm going to make y the subject because that means my x now becomes positive, and you substitute this y equals 3 plus x into equation A. So it becomes x squared plus y squared, but now we know y is equal to 3 plus x. So it's 3 plus x all squared is equal to 29. Now, all you have to do is you have to expand the bracket. So if I do a bit of rough working out here, 3 plus x squared is 3 plus x multiplied by itself. So if I take 3 times by the second bracket, and then x, positive x times the second bracket, I end up with 9 plus 3x plus 3x plus x squared. Tidy that up, 9 plus 6x plus x squared, and I'm just going to bring that over to the other side. And now we have x squared plus 9x plus 6x plus x squared is equal to 29. Tidy this up even further and gather like terms. So I've got 2x squared plus 6x. I'm going to bring the 29 over to the left hand side, so I need to subtract 29 from both sides. 9 take away 29 is negative 20, and the right hand side is now going to equal 0. Hopefully you can see that all of the terms here are divisible by 2. So I'm going to be left with x squared plus 3x minus 10, and that's going to equal to 0. And now I'm looking for two terms that multiply to give me negative 10, but add to give me positive 3. So that's going to be a combination of 5 and 2, and the 2 must be a negative. So coming back onto my left hand side, my brackets are going to be x plus 5 brackets x minus 2 is equal to 0. So either x plus 5 is equal to 0, therefore x is equal to negative 5, or x minus 2 is equal to 0, therefore x is equal to positive 2. Now all you need to do is substitute back into the linear equation. In this case, it's going to be y is equal to 3 plus x, therefore y is going to equal 3 plus negative 5. Y must be equal to negative 2. Or when x is equal to 2, y is equal to 3 plus x, y is equal to 3 plus 2, then y must be equal to positive 5. At this stage, just make it clear what your answers are. So we had x is equal to negative 5, y equals negative 2, x is equal to positive 2, y is equal to positive 5. Moving on to question 3, a worded question that is similar to question 2, but by eliminating, we're going to show that Tayyab is wrong. Let's dissect the question. So we've got y is equal to 6, let's call that A, which cuts the curve, which means the graphs intersect, they cross over, and therefore we can use simultaneous equations. And then we have the quadratic equation, which I'm going to label as B, x squared plus y squared is equal to 25. We just substitute equation A into equation B. So I'm going to be left with x squared plus y squared, but we know y is now 6, so 6 squared is equal to 25. And I'm just going to solve for x. Therefore, x squared plus 36 is equal to 25. To get x squared by itself, I need to subtract both sides by 36. And I'm going to be left with x squared, that cancels, is equal to 25 take away 36, which is negative 9. Now, in order to solve for x, I need to square root both sides. But I can't square root a negative number, so this x has no solution. Therefore, Tayyab was wrong. Graphically speaking, these graphs just never cross. Moving on to question 4. Solve the simultaneous equations. X squared minus 3y squared is equal to 13. 2x plus 3y is equal to 4. So this is a slightly trickier question, but we follow the same principles. We've got equation A with the quadratics, and we've got equation B with the linear terms. Just like before, we are going to rearrange the linear terms and then plug one of the variables back into the quadratic. It doesn't matter what you make the subject. I'm going to choose x. So from equation B, 2x plus 3y is equal to 4. That means I'm just going to subtract 3y from both sides, and that means 2x is equal to, cancels, is equal to 4 minus 3y, and now I'm going to divide both sides by 2, and I'm left with x is equal to 4 minus 3y over 2. The reason this becomes a little bit tricky is because now we've got a fraction that we're going to substitute back into equation A. X is equal to 4 minus 3y over 2. Let me just write that a bit clearer. And if I substitute that back into equation A, I'm going to have 4 minus 3y over 2 all squared minus 3y squared is equal to 13. So all I've done is I've substituted 4 minus 3y over 2 into x. Now, 4 minus 3y over 2 all squared is simply a fraction multiplied by itself. Multiply the numerator by the numerator and the denominator by the denominator. So if I do 4 times 4, which is 16, 4 times negative 3y, which is negative 12y, and then if I do negative 3y times by 4, which is again negative 12y, and then negative 3y times negative 3y is positive 9y squared, over 2 times 2, which is 4. Tidy this up, and I'm going to have 16 minus 24y plus 9y squared all over 4. I've just brought that over to the middle. I'm going to continue here. Minus 3y squared is equal to 13. General rule with algebraic fractions, get rid of the denominator. At this point, it might be worthwhile saying, check out my algebraic fractions video. I'm going to multiply this term by 4, this term by 4, and this term by 4. So if I continue here, I'm going to have 16 minus 24y plus 9y squared. Because the fraction is going to be cancelled out by the multiply by 4. Minus 3y squared multiplied by 4 is minus 12y squared. and then I'm going to have 13 times by 4, which is 52. Now, I've got a bunch of terms I want to tidy up. This is going to be, so if I start with the y squared, so now I'm going to gather like terms and tidy this up. I've got 9y squared minus 12y squared, which is negative 3y squared. Then I've got negative 24y. And then I'm going to bring the numbers onto one side. So I've got the 16, and I've got to take away 52 from both sides. In order to make this quadratic equal to 0, 16 take away 52 is minus 36, and that equals 0. If you notice now, all of these terms are negative, so you can divide the left-hand side by negative 1 and the right-hand side by negative 1. 0 divided by negative 1 is just 0. And then all the other terms, when you divide by negative 1, it just changes the sign. So this is 3y squared plus 24y plus 36. Now at this point, all the terms here are divisible by 3. So I'm going to divide 3y squared by 3, 24y by 3, and 36 by 3. Now I've got a much nicer quadratic to deal with. Now if I carry on my rough working, I need two numbers that multiply to give me 12, but they're going to add to give me positive 8. So it must be 6 and 2. So my two brackets are going to be y plus 6 and y plus 2. And they're going to equal to 0. Therefore y plus 6 is equal to 0 and y must be equal to negative 6. Or y plus 2 is equal to 0 and y is equal to negative 2. Now I've got my y values. I'm just going to substitute them into this equation so I can solve for x. So for my first solution of x is equal to 4 minus 3 lots of negative 6 all over 2. So that's 4 plus 18 divided by 2, which is positive 11. And for my second solution of x is equal to 4 minus 3 lots of negative 2 over 2, which is 4 plus 6 divided by 2. X must be equal to 5. Now I'm just going to clearly state my answers. When y is equal to negative 6, x must equal positive 11. And when y is equal to negative 2, x must equal positive 5. Thank you for watching. This has been Mr Miah at R Squared Tuition. Don't forget to like and subscribe, turn on notifications, and comment below any questions or topics that you would like me to cover.